So let's go over some terminology in this idea of our hypothesis testing. The hypothesis is a statement regarding a characteristic of one or more of our populations. Hypothesis, we should be familiar with that term from any science class we've had previously. Now, the null hypothesis, which we're going to denote as H sub 0, is going to be what we assume to be true. So this is going to be our information about the population, that assumption that we're going to assume to be true, where our alternative hypothesis, which we can generally see as H sub A, sometimes you might see it as H sub 1, this is usually what the researchers want to show. It's what they might think is happening, or it's what they think might be true. So you have your null hypothesis, which we are going to assume to be true, and our alternative hypothesis, which is what we the researchers, want to show. So here's an example where we can see in words what this null hypothesis looks like. Mars has generally, they used to post on their website the proportion of candy in their bag, so the proportion of colors for their candy in their M&M bag. So here's a claim about that population. The proportion of orange M&Ms in a bag of candy is 20%. So you can see here that we are assuming that is the true case, that we would expect M&Ms, orange M&Ms, in a bag of candy. Uh, we would expect 20% of them to be orange in the long run, right? That's that long run proportion or that long run probability. Whereas the alternative hypothesis is what we want to show, that the proportion of orange M&Ms in that bag of candy is really more than 20%. Or we would expect orange M&Ms more than 20% of the time in the long run. So those probabilities of what we would expect to happen in the long run, and also the idea that that null hypothesis is what we assume to be true. The alternative is what we want to show. Now, it's important to remember that in both the null and the alternative hypotheses, these are written about the population. This is a claim about the population. All right, so it's a parameter. And it is not going to be ever, your null and your alternative hypothesis will never be written in terms of our sample, which is our statistic, which we call the observed statistic in the long run. So null and alternative are always about population parameters, and they will never be about a statistic from a sample. The steps that we're going to look at for our hypothesis testing are going to start with these 5. We'll add to this as we move through this lecture. But the first 5 are important for us to understand. You've got to first determine what that parameter is you're looking at. Are you looking at a proportion, which is represented by P? Are you looking for a mean or an average quantitative variable, which would be represented by mu? Or are you looking at some sort of standard deviation of your population, which is represented by sigma? Once you've determined that parameter, of course, you would go in and verify those requirements of a normal distribution like you saw back in Chapter 8, where we were determining normal sample distributions. The third step is to make a claim regarding the population. So making a statement regarding that nature of the population becomes writing out your null and alternative claims. After that, you go out and you sample the data. And then the fifth step in this process is to analyze the data. Or in other words, you're trying to figure out, is it plausible that you're even going to get that result? Let's keep that in mind as we look back to an example we saw from Chapter 8. In this example, the mean weight gain during pregnancy is 30 pounds with a standard deviation of 12.9. An obstetrician believes that the average weight gain has increased. She obtains a random sample of 35 low-income patients and determines that their mean weight gain during pregnancy was 36.2 pounds. Let's see how this looks in relation to the steps of the process of our hypothesis testing that we just discussed. First, we've got to identify the parameter. In other words, are we looking at a proportion? Are we looking at a mean, or are we looking at a standard deviation? And you can see here that in the very first sentence, we are discussing average weight gain during pregnancy. So that tells us we're talking about a mu, or variable. Now, when we discuss verifying the normal distribution for a mu, or quantitative variable, in order for us to verify that distribution, we would say that the sample has to be greater than or equal to 30, because I don't know anything about whether or not the distribution comes from a skewed or a normal distribution. And the central limit theorem says as long as your sample size is over 30, then you're going to be okay. And you can see here that we have a sample equal to 35, which is obviously more than 30, so we have verified that we're good to go. Now it's time to make a claim or make a statement regarding the population. The null hypothesis is that statement we assume to be true about the population. So in this example, we see that the null hypothesis that we're going to make the claim about says that the mean weight gain during pregnancy is 30 pounds. So our null hypothesis, which is always that statement that we assume to be true, we're going to assume, okay, the average weight gain is 30 pounds. Symbolically, we represent it, like we said before, with h sub 0 at mu equals 30. So symbolically, we will always write this as our parameter of interest, which is mu, and then our assumption is that it's equal to 30. The alternative then is going to be what we want to show, or what the researchers think. And you can see up there that this obstetrician believes that the weight gain has increased. So the mean weight gain during pregnancy is more than 30 pounds. And that alternative symbolically will look something like this, that H sub A colon says that mu then is greater than 30. Notice that our null and our alternative hypothesis are both statements about the population's parameter, which is that average weight gain equal to 30. Step number 4 says you want to collect your evidence or your sample to test the statement. What does that look like for us? Well, this obstetrician sampled 35 low-income patients and determined that their average weight gain was actually 36.2 pounds. So X bar would be the average weight gain of these 35 patients. And then we would analyze the data to assess that plausibility of a statement. In Chapter 8, or previously, we did that, as a matter of fact, by using the normal calculator. When we answered this particular question, we used the normal calculator to find what's the probability of getting a sample X bar greater than 36.2. We found that by using the normal calculator. We adjusted our normal calculator with the mean of our sample means as well as the standard deviation of our sample means, and found the probability that X bar was greater than 36.2 as 0.002. So it was unlikely for this obstetrician to have an average weight gain from 35 women greater than 36.2. Now, how do we apply that information, that idea, to what we're looking at here? Well, we have this idea about a p-value. And in our example we're looking at, we found that that probability for women to have a weight gain greater than the population was really only 0.002. That is what we would consider our p-value. Now we can define a p-value as the probability of getting a result that is either the same or more or less extreme than our actual observations. That's our definition of a p-value. We use this p-value to measure the strength of our evidence against the null. In other words, we're measuring our sample against what we assumed to be true. So a small p-value is going to provide strong evidence against the null. In other words, the probability of getting an average weight gain from 35 women that is more than 36.2 pounds, we found was really only 0.002, right? So there are only 2 out of 1,000 trials of grouping these 35 women together. There's only 2 out of 1,000 trials where it actually happened. We assumed the average weight gain during pregnancy was only 30 pounds, but our probability is contradicting that assumption. What our p-value is now telling us is that we have strong evidence contradicting that assumption, or strong evidence against the null. That's how we can use our p-value, which is really the probability of getting our sample or more or less, in order to evaluate whether or not our assumption about the population is true.